Hello everyone, welcome to Target 45. My name is Jyoti. Today we are going to solve factorial of a number using two approaches, that is iterative and recursion approaches. Before discussing about this, if you have not subscribed to Target 45, please kindly subscribe it. Daily we are going to solve one coding problem in Python. So let's understand what is factorial. Factorial is defined as the product of numbers from 1 to up to that number and all are positive integers. This is known as factorial. We define factorial like this. So let's get into the iterative approach method. So first what we did, we defined a function which is factorial underscore iterative function. What we have to do, according to our definition, if the number is less than 0, we have to return factorial is not possible on negative numbers. This is the condition if n is less than 0. Otherwise, what we have to do, we have to take a result variable and we have to store the result in this variable. So we need to loop over from, we already stored the result as 1. So we need to start from 2 to n. We need up to n. So I'm using n plus 1 here. So what we have to do, we have to into I. We have to multiply the result with I every time throughout this loop until the condition is done, until n is 6. If n is 5, if we are passing n is 5 here, so until 6, so it will loop over this for loop for 5 times and it will stop execution. So we are doing this and we have to return result. This is that simple. We can write this as, even in the shortest form, like this. You can use any of these two. Both are same. So let's run this. Okay. See, the factorial is 120. So let's discuss again. Like what we are doing is, if n is less than 0, factorial is not possible for negative numbers. What we are doing, we are storing the result here. Initially, we are initializing result as 1 and we are multiplying this 1 with every time we are looping over this for loop up to 2 to n. And finally, once this entire for loop is done, we are returning the result. So that is why the factorial is 120 here. So we'll discuss this with an example. Here we are doing what, 5 factorial. So initially result is 1. So when inside the loop, when I equal to 2, the result is 1 into 2, that is 2. And when I equal to 3, result is 6. I equal to 4, result is 24. When I equal to 5, the previous result is 24 and we have to multiply with I, which is 5 here. So it is 120. When I equal to 6, it will come out of the for block. So this is how we have to do factorial of a number using iterative approach. Now we'll try to solve using recursion approach. At first, what is recursion? If a function is repeatedly called by itself until the base condition is reached. Remember, until the base condition is reached. This is known as recursion. So we'll do the recursion with we do the recursion for factorial. So again, what is our base condition? If n less than 0, this is a base condition here. We have to return factorial is not possible, or is not defined for negative numbers. And next thing we have to write is, what if n equal to 0 or n equal to 1? In this case, we have to return 1. And we have to return what? We are calling a function by itself using recursion. So what we need to call here? We need to decrement each time the n, so that recursion will be possible, because we are telling recursion you have to go from 5, 4, 3, 2, 1 and get all the result back and display the final result. And we also need to multiply with n. Why n? Because every time we are telling the previous result has to be multiplied with the number. So let's understand this with the, okay, we'll see what will happen for recursion factorial for 5. Here we have the explanation for factorial recursion. See, initially the factorial recursion of 5, it returns what? 5 into factorial recursion of 4. So we don't know what is factorial recursion of 4. So what it will do? It will again go and calculate factorial recursion of 4 with 4 into factorial recursion of 3. And again it will go and calculate factorial underscore recursion of 3 with 3 into factorial underscore recursion 2. In the same way, it will go for factorial recursion of 2, wherein it will multiply by 2 into factorial underscore recursion 1. Again, it doesn't know what is recursion 1 here. So again it will do factorial underscore recursion 1 is 1. If you see, factorial underscore recursive 1 returns 1, and it will pass this value to factorial underscore recursion 2, because it needs the value of factorial underscore recursion of 1. And here it calculates factorial underscore recursion of 1 with factorial 1 into factorial of 0. And here if you see, factorial recursive 3 returns 3 into 2. So in the same way, it does all these recursions and returns the final value as 120. This is how we solve recursion and iterative approach for factorial of a number in Python. Here if you see, recursion is not a good strategy if you have multiple function calls, because we can get an error called as stack overflow error. So it is not suggestible for programs where we have multiple function calls. So it is always suggestible to use iterative approach if you have more number of function calls. You can use recursion when there are less number of function calls, and iterative approach is more efficient when compared to recursion approach, because it can lead out to stack overflow error. Let's say we import this and see and see the recursion limit in Python. The default recursion limit in Python, it is 1000. The default limit for recursion calls is 1000. After 1000 calls, it will execute, like it will throw an error, recursion error. So just understand what this is, and you will get to know why recursion is not a good strategy when you have multiple function calls. So that's it for today. We are going to solve like this every day, and if you have any doubts in this today's code problem, please kindly comment in the comment section. We'll address it, and please kindly subscribe to Target 45. Thank you.